In our lesson today, we're going to have more practice working with equations of proportional and non-proportional relationships. In our last lesson, we learned that an equation represents a proportional relationship if it's in the form of y equals k times x, where k represents the constant of proportionality. Any equation written in this form will represent a proportional relationship. So in our first question, they want to know, does the question y equals 11x show a proportional relationship between x and y? So all we have to do is ask ourselves, does this equation look like the standard form of a proportional equation? We've got the y, and then we've got the k value. In this case, it looks like there's an 11 there, and then x. So if I matched it all up, y equals k times x, y equals 11 times x, this equation is in this form, so yes, this equation will represent a proportional relationship. Okay, now there's a couple of them that here that say yes. One says the graph is an equation of a straight line that passes through the origin. The other one says the graph is an equation of a straight line that does not pass through the origin. Well, on a graph, the straight line would have to pass through the origin, so it can't be H, so it's going to have to be choice G. Okay, this is the equation of a line that would be straight and pass through the origin. If it's a proportional relationship, then what's the constant of proportionality? Well, all we have to do is look at the equation, find k, and match it up. In this example, k equals 11. In our second example, it asks, does the equation y equals 3x plus 5 show a proportional relationship between x and y? So once again, we have to ask ourselves, is this equation in the form of y equals k times x? So once again, I'm going to write that right above the equation, y equals k times x. And I see the y, I see a potential k value, I see x, but I've got this plus 5 here at the end, which there's no plus or minus anything in our standard form of a proportional equation. So this actually is not the equation of a proportional relationship. So it can't be G, it can't be H, because it's not written in the standard form of y equals k times x. Okay, so we've got to ask ourselves, what does this plus 5 do to the equation? So if I graphed this, so here's our graph. Okay, we all know that the origin is where the x-axis and the y-axis intersect. Okay, if it was just y equals 3x, I would have a straight line that's passing through the origin. I would have something right here passing through the origin. But the moment that I add 5, okay, the line is going to get shifted up 5 units from the origin. So it's going to start here at 0, comma 5, and then it's going to be the straight line. Okay, because I've added 5, I'm going to shift the line up from the origin 5 units, starting at 0, comma 5. So when it says that the graph is not a straight line, well, that's not true. It's still going to be a straight line, but it does not pass through the origin. Okay, that's the reason why. Anytime you add or subtract from this standard form, you're going to shift the line away from the origin. Okay, so if it said y equals 3x minus 2, okay, that's going to shift the line 2 units down from the origin and then would be a straight line. Okay, so again, if it's not in the form of y equals k times x, then you know the equation does not represent a proportional relationship. In the next section, we're going to create equations from tables of values. For each of the following tables, find the constant of proportionality k and write the equation for the proportional relationship. All right, we've learned before that if we have a table of values, in order for there to be a proportional relationship, we have to see if there is a constant unit rate. So in my table, I have my x values in this column, I have my y values in this column. I have to set up my rates. Remember that the rates are always set up as the dependent variable y over the independent variable x. So we're going to set up each of these as y over x. With our first set of data, y is 10, x is 5, so our rate is going to be 10 over 5. We need to simplify that down to the unit rate by dividing each number by 5, which would give us 2 over 1. Our next rate from the table, y is 6 when x is 3, 6 over 3. Divide each number by 3 to get the unit rate, and we end up with 2 over 1. Our next rate from the table, we have y is 2, x is 1, so we get 2 over 1. And this is already a unit rate because the denominator is a 1. With the last set of data from the table, x and y are both 0. There's technically not any data here for us to create a ratio, so we're going to ignore that one for right now. Remember, though, that this is the origin if we were to put this on the graph, so we would need the origin in order to have a proportional relationship. So that's a good sign there. And notice when I look at all of the unit rates here, I see that the unit rates are the same. All right, so our constant of proportionality, k equals whatever we got when we did y over x. So in each case, when we did k, we got a value of 2 over 1 or 2. K equals 2 over 1 or 2. Now we can create the equation since this is a proportional relationship. When it says y equals k times x for the equation, all you do is replace the value of k. So in this example, since k is 2, our equation is going to say y equals 2x. That is the equation for this proportional relationship in the table. In example number 4, we have another table of values, the x column, the y column. We're going to do the same thing. We're going to set up our rates as y over x to see if we can figure out the value of k. With our first set of data, again, this is the origin. There's no way that we can make a rate out of it, but we would need the origin for there to be a proportional relationship. So we'll move on to the next set. When y is 5, x is 1. So our rate says 5 over 1, and that's already a unit rate. Our next y is 10 when x is 2, 10 over 2. Divide both numbers by 2 to get the unit rate, which would be 5 over 1. And finally, when y is 15, x is 3, 15 over 3. Divide each number by 3, and we get 5 over 1. So we have the origin, which is perfect. And notice that when we simplify down the rates, we get the same unit rate here. Our k value, constant of proportionality, k equals 5 over 1 or 5. Now we need to make the equation. Again, it's got to be in this form of y equals k times x. K in this example is equal to 5. So the equation is going to say y equals 5x. That is the equation of this proportional relationship. If you were ever working through a table and you noticed that when you simplified, you didn't get the same unit rate, then it would be a non-proportional relationship. And for the constant of proportionality and for the equation, you would just write n/a. It would be non-applicable. In the next section, we're going to use word problems in order to come up with the equation of the relationship. What you're going to want to do for your word problems is see if you can figure out the unit rate and then what the value of k, the constant of proportionality, would be. In question 5, it says a car manufacturer completes 39 cars every 3 minutes. They want us to write an equation to represent the total number of cars, which is our y value, for x minutes of production. Okay, x is the number of minutes, which means it's the independent variable. The number of cars that they produce depends upon the number of minutes, so the cars is the y value. So when we set up our rate as y over x, we need to do the number of cars over the number of minutes. And in this example, it says that they can complete 39 cars in 3 minutes. So that means we need to divide each of these numbers by 3 to figure out what our unit rate is going to be. And that's going to be 13 over 1. So they can do 13 cars per minute. Since they can do 13 cars per minute, that means that our k value, the constant of proportionality, equals 13 or 13 over 1. Okay, now that we know the k value, we can easily make our equation. Remember, it has to look like y equals k times x. Well, since k equals 13, the equation is going to say y equals 13x. That is the equation for this word problem. In example 6, it says recently the exchange rate for US dollars to Indian rupees was 45 rupees per dollar. Write an equation to represent the rupee total, which is your y, for x dollars. Okay, so again, when we do our rate as y over x, we're going to do rupees over dollars, okay? Well, right here, they tell us it's 45 rupees per dollar, which means our rate is 45 over 1. So this is the unit rate, 45 rupees per dollar, which means that K, the constant of proportionality, is 45 over 1, or just 45. That means that the equation for this example would be y equals 45x. Just replace 45 with k in the proportional relationship equation. Y equals 45x. In example 7, you paid $2.50 for 5 apples. Write an equation to represent the cost, which is our y variable, of buying x apples. All right, so we can buy as many apples as we want, which is why it's the independent variable x. The cost depends upon how many apples we get, which is why cost is dependent. Y over x means that we're going to be doing the cost over the apples. And in this case, it was $2.50 for 5 apples. We need to divide each of these numbers by 5 in order to get our unit rate, which is going to give us 5/10 over 1, which means that the unit rate means that it is 50 cents per apple, and your constant of proportionality is the 5/10. Okay, so for this example, our equation, when we replace k in the equation, it's going to be y equals 5/10 x. That is the equation for this word problem. In the next section, we're going to use graphs to figure out what the equations are going to be. In our first graph, all right, we have to figure out if we have a proportional or a non-proportional relationship. Remember that on a graph, you need to have a straight line that passes through the origin in order for there to be a proportional relationship. If you don't have a straight line, or if it doesn't pass through the origin, then you know it's a non-proportional relationship, and you wouldn't be able to create the equation because there isn't a constant of proportionality. In our first picture, though, we clearly see a straight line, and I can see that it's passing through the origin here, so I know this is the graph of a proportional relationship. I need to figure out what the value of k, the constant of proportionality, is. Remember that on a graph, you can find the constant of proportionality by going to the point of 1, comma, k. All right, remember when we set up our rates, we always do y over x, and we need the denominator to be a 1, which is why we always go to 1 on the x-axis. So our x-coordinate is 1, comma, something. We're going to figure out what that is. In this example, if we come to the x-axis here, find 1. Here's where 1 is. Go up until you hit the line, and then if you come over to the y value, we're here at 10. Okay, so in this example, the y value is equal to 10. So y over x equals 10 over 1, and this is your k value. So the constant of proportionality, k equals 10 over 1, which is the same as 10, which means that the equation for this graph is going to be y equals 10x. Just replace k with its value in the equation, y equals 10x. In our second picture, again, we have a straight line and it's passing through the origin, so I know that this is a proportional relationship. And just like I did over here, I have to go to 1 on the x-axis first, go up till I hit the line to figure out what that y value is. So when I come to the x-axis, here's 1. I go up until I hit the line, and I hit it here when the y is 20. So when I do y over x, in this case, I have 20 over 1, and this is your k value. So the constant of proportionality k is 20, making the equation y equals 20x. Okay, remember, if you had a non-proportional graph because it's not a straight line or it doesn't pass through the origin, you couldn't do either one of these and you would say n/a, not applicable. All right. Now, since this was a proportional relationship, I can use this equation to answer a question. It says, what is the distance after 11 hours? So I'm going to use this equation, 11 hours. Well, if I look on my graph, the time in hours is on the x-axis, so I'm going to substitute 11 in for x in this equation. Y equals 20 times 11. And if you were to go ahead and multiply 20 by 11, you would end up with 220. Okay, so that means that the distance traveled after 11 hours is 220, and they're measuring it here in kilometers, 220 kilometers. In example 10, it says that your friend uses the equation y equals 8.5x to calculate the total cost, which is your y variable in dollars, okay, for x movie tickets. Okay, y equals 8.5x is used to calculate the total cost y in dollars for x movie tickets. Question A asks, is the relationship of dollars to movie tickets a proportional relationship? Okay, well, in order to figure that out, since they gave us an equation, remember that for an equation to represent a proportional relationship, it has to be in the form of y equals k times x. So I'm going to write that right above here and see if it matches up. Y equals k times x. And here, notice that there's nothing added or subtracted to it. It looks like it's in this form of y equals k times x. So I'm going to say, yes, the relationship is proportional. The relationship is proportional. And I know that because the equation is in the form of y equals k times x. Okay, any equation written in that form represents a proportional relationship. Letter B says, what is the constant of proportionality and what does it represent in words, meaning the unit rate? What is the unit rate? Well, let's start with k, the constant of proportionality, and that's easy. If I come up back to my equation, k is the constant of proportionality, so I look and see what's in its spot, and it's 8.5. K equals 8 and 5/10. What does it mean in words? What is the unit rate? Well, the unit rate, okay, since this is representing the cost of movie tickets, this means that it is going to be $8.50 per ticket. Okay, the unit rate for this is $8.50 per ticket. So question C asks, how much will 13 movie tickets cost? Use the equation. So the equation says y equals 8 and 5/10 x. 13 movie tickets is what we're buying. Back up here, x was the number of movie tickets, so substitute in 13. Y equals 8.5 times 13. And so all you have to do is multiply 8.5 by 13. And when you do that, you should come up with a value of y equals 110 and 5/10 when you use your calculator. Now, what does that mean? This means 13 tickets. This means 13 tickets cost $110, and we have to have two decimal places there, 50 cents. 13 tickets cost $110.50.